Okay, now we're going to get on to solving the problem, if you will. There have been a lot of findings here. I'm going to try not to bore you with too many details here, but I do have a good sense of the field. The field of Alzheimer's disease in terms of treatments is a wonderful example to all of you folks looking in the field of neuroscience on how research and treatments actually work in a disease state. You may have heard of lots of different treatments that may be useful for Alzheimer's disease, but remember the key process that they have to go through. It's clinical trials. And clinical trials are very rigorous, scientifically based, and you really need evidence to get a product approved on the market. Now, the latest one, and it's on the outline hot off the press, if you will, the latest group of products that they've been trying to develop have been products where they're trying to slow this process of the amyloid plaques forming in the brain. Did I use the word amyloid? I think I did in the previous one, but when A-beta peptide aggregates, it forms amyloid. I should have said the word amyloid, but I'm not sure if I did. It forms these amyloid plaques. So one group of treatments that was recently developed was the idea of, hey, let's just slow down the amyloid process, the building up of all this amyloid, which kills neurons and causes these plaques. So if we could do that, we'd be in very good shape. So Pfizer and Johnson & Johnson in one joint venture developed such a product. And boy, I love saying this name. Let's see if I can get it right. Bapimzumab. They developed Bapimzumab. I don't want to say that too much. Which was a product that basically reduces amyloid formation. And they took this through some animal studies. It looked good. And then remember the phases of clinical trials? Phase 1, just to see if it's safe and effective. And it was. Those 27 research institutes recruited people, tried the drug, small group. Phase 2, you can see on the abstract that I've included here. Phase 2, also looking good, that they gave this to people. It looked safe. It looked reasonable. Double-blind, placebo control. It looked like it was actually helping people out. But then the key phase is phase 3. And if you look at the very bottom of that page, you'll see, and this was just 4 or 5 months ago, that a trial just came out, phase 3 clinical trials. And look what it says there. It didn't help at all in the big groups in the clinical trials. So this one, which is trying to reduce the amyloid plaques in the brain, is off. And there were about 3 or 4 products like this. So this is what happens with Alzheimer's disease. Products come up, products look interesting, products look good, but then when it gets down to the science of clinical trials, a lot of these things just don't muster up. The next great hope, if you will, if you turn to the next page, the next great hope is B here. If you remember when I talked about the process here, we said the first thing that goes wrong is you have amyloid precursor protein. And remember what I said goes wrong? Beta and gamma secretase cleave this APP and lead to the formation of beta peptide. What if you could come up with a drug that could stop these enzymes from cleaving APP? Would that be useful? Yes, that would be very, very useful. And what we see now on the docket, hard to say whether or not it's going to work or not, but the idea is good. I'm portraying this in a very watered down way, is now you've got Merck and Eli Lilly partnering up and trying to, actually it was presented at the International Alzheimer's Conference back in May, I think it was. Merck apparently has a product very early on in clinical trials called MK-8931 that seems to block this particular buildup, if you will, blocks the beta and gamma secretases. So this will be the next big one that hopefully we find out. And if it could really stop that, that would be wonderful. So I just share those two as two that seem rather useful. And actually, I think I'm going to move ahead in the outline here and skip on number 3 for just a minute. I'll come back to that. I might change this in your outline, but if you want to turn to number 4, tried and failed, if you will. A lot of things have been tried. They've tried curry powder, if you will. They've tried ginkgo biloba. That doesn't seem to have much impact. Tried and failed. Aspirin, non-steroidal. Remember we said that part of the problem in Alzheimer's disease is inflammation. Well, if you could reduce inflammation, maybe that would be good. But if you look at this particular trial, they did a Cochrane database review where they summarized everything, and they basically found that they don't really work so well to help Alzheimer's disease. If you go to the next page, some of you have heard about estrogen being useful. Well, one big study, the Women's Health Initiative Memory Study, was really looking at this, and they gave estrogen to people, and they basically found that it didn't help at all. In fact, when people started getting too much estrogen, it seemed to have a detrimental effect. So estrogen doesn't seem to be a candidate. Statins, things like Vioxx and Celebrex, kind of super aspirin, if you will. They tried that in some clinical studies, and they basically find with a Cochrane database review that that didn't seem to work either. So a lot of these things have gone on. They've brought them up, they've tried them, and they haven't really worked so well. What I wanted to go over are the products that are actually being used now next for us. So this is Roman numeral 3. Notice the picture I put here. Does this picture look familiar? I hope it does. Can you see the idea of how you make a neurotransmitter? Synthesis, storage, release, binding, change in electricity, and then reuptake? That was what we learned in the first part of this class. Well, work has been done with Alzheimer's disease, and they've identified a couple of neurotransmitters that seem to play a role in this. The first one they identified, and I hope I put this on the next page, Aricept, donepezil. It seems that one thing that happens when people have Alzheimer's disease is the following. The neurotransmitter acetylcholine is made, it's synthesized. It's when you take an acetyl group, combine it with a choline group, it's stored in the vesicles. When an action potential comes down, the acetylcholine is released. When the acetylcholine binds, that is a good thing. But for people who have Alzheimer's disease, they don't seem to have enough acetylcholine working. And so one way to increase acetylcholine working is to get more of it to bind. And so the way they do that is, one of the things we know about acetylcholine is after acetylcholine binds at the postsynaptic region, there is a enzyme that comes in. The enzyme is called acetylcholinesterase, if you will, acetylcholinesterase. That usually destroys acetylcholine. The drug Aricept will block acetylcholinesterase from working. And so by blocking this enzyme that normally destroys acetylcholine, and I hope you're following what I'm saying here, it seems to increase the amount of functional acetylcholine in the synapse, and thus seems to help people with Alzheimer's disease. So Aricept is actually an acetylcholine agonist. It'll increase the amount of acetylcholine by blocking the enzyme that turns it off, if you will. And so that seems to help people with Alzheimer's disease. And if you look at the abstract, you can see that this is a phase 3 clinical trial. They did it. One of the typical ways to measure if something is working is the mini mental state exam. And they found that when they gave this, people were generally doing better. And it was helping their Alzheimer's disease. Do I even have an abstract of that? Yes, I do. If you turn a page or two in, this is the data from Pfizer, who came up with donepezil, showing that on the mini mental state, it seemed to help people out a little bit. So this product increases acetylcholine level, seems to help people with Alzheimer's disease. The problem is it's not going to work for a very long period of time. This disease is causing huge problems in the brain. Just changing little levels of acetylcholine is way at the end of the pipeline, so this one isn't going to be terribly useful. The other product that has been used successfully and is a more recent product is the next abstract, memantine. It seems memantine is a product that blocks glutamate, which might be surprising to you, but I'm not going to go into a great amount of detail here, but it's found that glutamate seems to be involved in one of the problems with Alzheimer's disease is at times there's almost too much glutamate activity. And so memantine seems to block the receptors. Notice it says it blocks it at low to moderate affinity. It works at a receptor, a glutamate receptor, that's actually been implicated in long-term potentiation. It's called the NMDA receptor, but it seems to block glutamate, and when it's used in combination with Aricept, which is working at acetylcholine, it seems to work reasonably well. So these are the only products that are used now currently on the market, and hopefully that makes some sense for you. I think I'm going to cut this one at this point, and then move on to the last one.